Hi, I am Ifat, and this is our Java Swing Blokus game project developed as part of a five-member academic group project. Um, Blokus is just a game. It is a turn-based strategy board game played on a 20 by 20 grid. Each player takes turns placing differently shaped pieces onto the board. The objective of this is basically is to put or place as many pieces as possible before no valid moves remain. The main rule of the game is that your own pieces can only touch at the corners and cannot touch by the sides. That's basically it. Now, starting from the main menu here, the player can begin a new game, load a game, and view the game roles. I'll start a new game. I'll start with a new game. So if we click new game, inside the setup, this is the setup screen. Inside the setup screen, players can configure who participates in the match. For this game, I'll keep the player 1 as a human, set player 2 as AI with the difficulty easy, and player 3 will keep them as human as well, and the player 4 will put it as hard, right? Now the setup menu also supports additional customization like text size, and you can show or hit corners, and of course the color modes. It gives you different color palettes. Now once the game starts, I'm gonna do start game. So now once the game starts, the board and players trays are initialized. You can see each player has their own collection of available pieces displays in around the board. When a piece gets used, it automatically disappears from the tray because the game state system checks which pieces have already been placed. One of my main contribution to this project was the core game logic and state system that controls everything happening during the gameplay. So here I'll make a first move. So this is my player 1. I can select a piece, rotate it, and place it onto the board, right? So this is where I can place it onto the board. Before the move is accepted, the game validates whether the placement follows the official Blokus rule. For the first move, the piece must cover the player's starting corner. Internally, the board is represented as a 20 by 20 grid where every cell stores both the owner and color of the occupying piece. When a move is attempted, the validation system checks several conditions, including board boundaries, overlap detection, valid corners, connections, and illegal side contact with other players or with the current player's pieces. Now, after the first move, future pieces must connect through corners and cannot touch player's own pieces by side, right? So I'm gonna show you once we are on the player 3. Uh, so okay, so I believe you guys missed it, but once I place the player 1, our easy player AI put his pieces randomly in there. So we're gonna explain that later on. So let's go to the player 3 so we can choose the player 3 again. So here you can see if I try to place the piece incorrectly, the game rejects the move because the role validation detects an invalid side connection. So if I try to put it anywhere else, here, it's not gonna work until I put it to the correct place, and then the other AI players puts the piece, and the move comes back to the player 1. We're gonna explain the AI players later on. So another important feature I implemented is the valid corner tracking system. As you can see, after every move, the game recalculates which corner positions are legal for each player. These valid corner positions are used both for move validations and the optional corner hint system displayed on the board. So for example, you can see I only had one corners there in the beginning, and now I have 1, 2, 3. So these are the valid corners that I can place the next piece to. Now I can turn this off from the settings, icon, and then I can turn it back on again. It comes back again, right? Now, the game state class itself tracks the board states, current players, used pieces, scores, and valid corners in one centralized structure. This helped keep the gameplay systems organized and also made save and load support easier to implement later on. Now, it's the easy AI player's turn, right? So let's put another places, right? So as you can see, if I try to put it anywhere else, it's not gonna work, right? Until I put it in a correct place. So now the easy AI, right? So you can see it put another correct pieces there, right? Now the easy AI searches through possible legal placement and randomly selects one from the valid moves that are available through the corners, right? So even though the strategy is simple, it is still fully follows the Blokus rules and use the same validation system as the human players. So the validation system itself is same. The AI players just looks through all the valid placements that are available, and this easy AI just puts a random piece there. Just picks a random piece, picks a random rotation, just puts it there. No extra stuff. Now, if we go to the hard AI, now that's where we do have some more calculations in there. So let's go ahead and go with the player. So now for the hard AI, as you can see, it puts another pieces in there. Now the hard AI evaluates possible moves using a scoring-based system. It considers factors like piece size, future corner opportunities, board expansion, and movement towards the center of the board. So as you can see, the AI player, if I put a couple of more pieces, you can see the difference, hopefully. As you can see, the hard AI does not just place random pieces. It first checks all possible valid moves by testing different pieces, rotations, and board positions using the same game rules as the human players. After that, it gives every possible move a score based on how good the move is. Bigger pieces usually get higher priority because they become harder to place later in the game. The AI also looks at how many new corners opportunities a move creates, since more corners means more possible moves in future turns. It also tries to spread across the board and move toward the center to avoid getting trapped in one area. After scoring all the possible moves, the AI chooses the move with the best overall value. I also added a small amount of randomness so the AI does not play the exact same way every single game, which makes the gameplay feel more natural, right? For example, if we put hard AI on both, the heuristic values are same for both AI, right? So and it's gonna just keeps putting same exact pieces every time for all the AIs every game. So that's why I put some randomness, slight randomness into the evaluation system so the hard AI does not repeat the exact same move pattern every game, right? Now, when an AI turn begins, the AI reads the current game state, generate valid placements, evaluates possible move depending on difficulty level, updates the board, recalculates valid corners, refresh the scores, and then automatically passes control to the next player. Another feature connected to the game state system is save and load functions. Because the important gameplay data is stored on in one serialized structure, the game can save the current match and later resume from exactly the same point. So if we go to the settings, we can just do save game, and let's just choose a spot. We're gonna choose this empty spot, and then it saves the game. So now if we want to load the game, we do have a couple of other loads, so I'm gonna just show you. So here you go. This is another load game that was previously there, and then if we go in and load the recent one that we just saved, it's right there. Now at the end of the game, scoring system calculates penalties based on remaining unused blocks. Players who place all pieces receive bonus points, including an additional bonus if the final move uses the single tile pieces. Once no players have any remaining legal moves, the game automatically detects the end condition and displays the final scores and winning screen. Now, let's see if I can find any of those pre-saved that have. Okay, so here we can see all these AI players have no moves left, only the human players have those moves left. So I'm just gonna try to put the pieces here so I can get the game. Yep, so there you go. So the game over, and then it's showing which player won the game and the scores. And then of course you have the option to start the new game or exit the game, right? Now, from a software design perspective, the project was separated into multiple packages for maintainability. The UI package handles rendering and screen. The game packages handles the rules and state management. The AI packages handle the automated gameplay behavior, and the save packages handles the serialization and loading system. And yeah, that's pretty much it. Thank you for watching, and this is our Blokus project.